Good evening, sir, and my fellow friends. Today I'm going to present on the title of Multimedia Storage Devices with a special focus on solid state drivers or SSDs. By the way, my name is Danish and I like Ajin Takuma. Today I am going to explore about how various storage technologies support multimedia needs, especially in high performance environments like video editing, gaming, and cloud computing. Okay. What are multimedia storage devices? Multimedia storage devices are hardware components used to store digital content like images, audio, video, and documents. In today's data driven world, the performance of this storage system directly affects how efficiently we create, share, and consume multimedia content. Types of multimedia storage devices. Let's brief look at five main types of multimedia storage devices. First of all, hard disk drives, we call as HDDs, use spinning disk to store data magnetically. They offer high capacity at a low price but are slower and more fragile. The next one is solid state drivers, or we call as SSDs. Use flash memories with no moving parts. They are fast, durable, and increasingly popular in performance heavy tasks. The third one is USB flash drives. Are portable, plug and play devices are ideal for quick data transfer and backups. The fourth one is memory cards, such as SD and micro SD cards, are compact and commonly used in smartphones, cameras, and drones. Lastly is optical discs like CDs and DVDs use laser technologies and are mainly used today for media playback and archival storage. Here's a comparison of these devices across key factors. First of all, HDDs provide high storage capacity at low cost but are slower and less durable. The second one is SSDs offer superior speeds and reliability but at a higher cost per gigabyte. The third one is USB flash drive and the fourth one is memory cards offer moderate speed and are very portable. The last one is optical discs are inexpensive but limited in speed and capacity, mainly suited for achiever. As we see next, SSD stands out in terms of speed and performance. Here the slide shows the differences between the current usage of multimedia storage devices in the year of 2025 in the form of percentage. First of all is HDDs, which is 25%. The SSD is the majority higher, which is 75%. The third one is USB flash drive, which is 50%. The fourth one is memory cards, which is 40%. And finally, which is optical disc, which is 10%, which is the lower majority. Here shows how SSD works. SSD use NAND flash memory to store data electronically. Unlike HDDs, they have no moving mechanical parts. This architecture allows SSD to access data almost instantly, leading to fast boot times and smoother media playback. Data is stored in memory cells and retained even when power is off. Here are the types of SSDs. There are several types of SSDs based on connection interfaces and form factors. First of all, SATA SSDs use the same interface as traditional HDDs but are much faster. The second one is NVMe SSDs, connect via PCLE links, offering lightning fast data transfer rates. Third one is M.2 SSDs are compact and often used in laptops and desktops. The fourth one is PCLE SSDs are typically used in high-end workstation and gaming system for extreme performance. The last one is visual. As we are currently see, visual is the interface comparison chart or photo. Each type is suited to different devices and workloads. Here are the advantages of SSDs. SSDs bring several advantages. First of all, blazing fast speed for reading and writing data. The second one is higher durability since they are shock resistant and lack moving parts. After that, lower power consumption, which extends battery life in laptops. Finally, silent operation, no spinning disk or vibration. This makes SSDs ideal for multimedia intensive tasks like 4K video editing or real time gaming. Here are the limitations of SSDs. Despite their advantages, SSDs have some limitations. First of all, they're more expensive per gigabyte compared to HDDs. Second one is they have limited write endurance, meaning each memory cell can only be written to a certain number of times. However, modern wear leveling technologies have greatly improved SSD's longevity, especially for average users. Here are the real world SSD usages. SSDs are used widely across various platforms, such as in personal computers, they provide faster system performance and boot times. The second one is in professional multimedia workstation, they allow smooth editing of high resolution videos. Other than that, gaming consoles like the PS5 and the Xbox Series X use SSDs for faster load times and seamless gameplay. Finally, in data centers and cloud performance, SSDs endure fast data access and lower latency for millions of users. Here are the SSD trends and future outlooks. SSD technologies has seen major improvements from SLC to QLC. We now store more data per cells, increasing capacity. 3D and AND stacks memory vertically for better density and performance. Technologies like Intel Optane aim to bridge the gap between the memory and the storage. The future SSDs involves faster, denser, and cheaper storage, enabling real-time 8K editing, VR content, and smarter cloud storage system. Here are the summaries and conclusions. To summarize, I explore different types of multimedia storage devices and its uses and comparisons. SSDs stands out for their speeds, durability, and relevance to modern multimedia workflows. Advancement in SSDs technologies are shaping the future of digital content storage and delivery. So let's continue to explore and embrace this fast moving storage evolution. These are the references that I'm going through for this entire presentation slide. Finally, thank you, sir, and my fellow friends, for the time you all give for me, and thank you very much.